So I hope you're okay with molecular weight and formula weight, and we're going to be coming back with those here in a minute. But I want to talk about moles again. Oh, I love the mole. So the mole actually is a way to kind of talk about a bunch of particles at once. It's a parcel of particles or molecules or formula units or basketballs or snowflakes, 6.022 times 10 to the 23rd of those things. That's what a mole means. 6.022 times 10 to the 23rd is what we call Avogadro's number. This is kind of a review slide from a previous unit. We abbreviate mole. Remember, you get to drop the E. Is that not fun or what? It's based upon one isotope of carbon-12, so that's a mole. And remember, we talked about we can use a mole with regard to an equivalency statement. So this down here is the mole in an equivalency statement. Now you probably know what's coming up here in a minute. We can use any equivalency statement to make a ratio, or what we call a conversion factor. So that's what's coming up. Well, earlier, I lose track of which unit it was, but we talked about the concept of a mole, and it works well with atoms. So if you have 6.022 times 10 to the 23rd atoms, you have 1 mole of atoms, right? And like I said, you can take any equivalency statement and you can make 2 ratios out of them, okay? And actually we kind of talked about how these ratios are really equal to the number 1. So we can kind of use them to multiply things through, and we're like multiplying by 1, which doesn't, affect it. So I want to take it from atoms, though, now to molecules. I bet you'll buy this. If a 1 mole of anything is 6.022 times 10 to the 23rd of that thing, if you have 1 mole of molecules, you have 6.022 times 10 to the 23rd molecules, right? And we can use that then to work problems. For instance, and these are for instance, well, I guess I did kind of take them one at a time. Well, I did put them both up here. For instance, if I have molecules and I want molecules to cancel, I'm going to go ahead and be left with moles. I'm going to pick this one. Okay? If I have moles and I want moles to cancel and be left with molecules, I'm going to pick this one. So remember, it just kind of depends on how your problem is, what you need to cancel. Remember how that works? Okay. So it's a slight difference, but for ionic compounds, we call that repeating unit not a molecule, but we call it a formula unit. So we have this relationship for ionic compounds. If you have 1 mole of repeating formula units, then you have 6.022 times 10 to the 23rd of those repeating units, formula units. And we have 2 possible ratios that can be used as what we call conversion factors in working a problem. Okay, so I think that's where I'm going to end it for now.